My name is Squire. This is the Consultancy stream. My presentation is grandly titled "The Future of Food Hygiene," and it's a presentation about our project with the Food Standards Agency. I'll start off with a bit of an introduction. So I work for a company called decisionLab. We're a small OR and data science consultancy, independently owned. We work in three areas: simulation, optimization, and machine learning. These are some of the clients that we work with. We work with some really cool clients, really interesting projects. DSTL, we've done some medical evacuation simulation modeling, Thames Water, optimized investment planning over 20-year horizon and beyond. Rolls Royce, fault forecasting using advanced machine learning. Chris was on that project. And lots and lots of others. That's just a selection that I happen to know about. Okay, so for this particular project, the client was the Food Standards Agency. Now, their role is food hygiene and food safety. As anyone who's been to the developing world and got deli belly from a bad curry can attest, quite important. They're basically responsible for keeping us safe from bad food and food poisoning and all those horrible things. So they have, part of that remit is about overseeing food inspections of food establishments like restaurants and cafes and so on. And part of that process is the food hygiene rating scheme. So when you go into a restaurant, you can see on the door quite often there's a rating 0 to 5. If they've got a 0 or a 1, not good, don't go there. 5's obviously fine. So they don't actually do the inspections themselves. They just kind of provide oversight, and then a lot of the inspections are actually done by local authorities. So Manchester Council or locally here, Birmingham City or whatever it is. The context for the project is they've got this big overarching project called Regulating Our Future, which is all about kind of modernising the food regulation process, which is necessary, as I've sort of found out. They're kind of moving that into the future. So that's where this project sits. So specifically, let's say all of us in the room want to start a food business. We could start a hipster tofurkey and oat milk latte stand, because I've got the moustache for it. Let's say we did that. We would register with the local authority, register with Birmingham City Council or whatever it is, and we just say, we want to start a business. We give the name, give the address, and then the current regulation is within 28 days the local authority would have to inspect us. And of course we wouldn't be the only business registering. There's lots of different businesses that would register within the month, and essentially at the moment the local authority has no ability to prioritise their inspections. So some of them, we could be really good, we could have high hygiene, someone could be some dodgy other hipster latte business could be really unhealthy. So essentially underlying all this, there's some ratings that we're going to get, so you can see them kind of lined up here. And let's say this is the way that Birmingham local authority inspects us. We can see that actually there's a really risky business. At the end, they might pick the first one first. And that's an issue because this one waits longer to be inspected, and it's got a certain amount of time before it gets, it could be causing issues within Birmingham. And also there's limited resources, so it doesn't always work out as 28 days. There's lots of other stuff going on. It's not just new business inspections. So prioritising those inspections is potentially a very useful thing for local authorities. Better use of resources and lowers risk. So the idea for the project was essentially to develop a machine learning model, or an appropriate model, that would help the local authority prioritise their inspections. So that's what we went about doing. So at the point of registration, we'd provide a bit more information about our business. So rather than just giving the name, we'd say, okay, what are our opening hours? Are we doing high risk processing? Any of that kind of stuff. So the first part of this project, which is quite often the case, it's not the fun part of a data science project, but it often takes up the bulk of the time, is getting hold of the data, cleaning the data, all that sort of stuff. So as I mentioned, the food hygiene process quite often is not really living in the 21st century. Most are conducted on paper. So your local inspector will go around with a clipboard and a piece of paper. If you're lucky, that gets scanned into a system. If you're really, really lucky, and 4 of 350 local authorities do this, they use an app to enter the data. So that's fairly extractable as a spreadsheet. So although not that exciting for your purposes, this probably took up several months of my time collecting data from about 10 local authorities. I put a little star here for GDPR if ever you're working on projects like this. Don't forget that. So that caused a lot of issues. If there's any personal data involved, that's a real, can be a real sticking point. And also, actually, the Food Standards Agency have an API where you can get hold of just the ratings of businesses as well. So that's an interesting data set if you guys are interested. So what sort of data did we end up getting about businesses? So this is data that's collected by inspectors. They're collecting things like business name, location, the kind of obvious stuff, opening hours. Does it have a food safety management system? So do they kind of have those right management processes? Do they have waste collection contracts? Do they have pest control contracts? There are loads of all sorts of stuff, either doing sous vide cooking. So we're trying to look through this data and find what is predictive of kind of good or bad behaviour. And we also, very worth noting, it's a very unbalanced data set. So only about 5% of establishments fail. So it's quite hard. It's almost needle in a haystack type problem. Not quite, but it's very unbalanced. So it's a little bit difficult. If you were just trying to randomly pick a business that failed, you probably wouldn't be able to do it because there's so few that do. We also drew in other data sets like census data and rateable value of properties in the area, just because that may well be predictive. Next step in the data science process is, that we went through is feature engineering. So this is just a few of the steps that we did that are kind of interesting. Things like intuitively, if you were trying to predict whether a business was compliant or non-compliant, you would maybe look at the name, and that would tell you quite a lot. So if you know it's a chain like Tesco's or McDonald's, you'd think maybe they've got a kind of a process in place. If it's called, Dave's Dodgy Kebabs, maybe not so much. So drawing out things from the name of the business, you can look at you can cluster around the names and stuff like that. So Cake and Bake, that indicates it's a bakery, so perhaps there's something in there. And same with chains, that was an important thing. So you just look at the frequency of occurrence. You also looked at the location, so you might think that similar businesses are clustered together in a certain area. Maybe there's an area of dodgy curry shops or whatever it is. Cool. So then, having done all that, having done the data extraction, the data cleaning, we applied some different machine learning models. And this is quite an important part for the project. You can have more powerful models that generally perform better, but they're often less interpretable. So there's always a trade-off in this process. And for this project, interpretability was really important because it's going to go into legislation. It's going to be, the government and government bodies are going to be acting on the advice, so it needs to be fairly explainable. As I mentioned before, the data was very imbalanced. It's probably worth saying we were modelling this as a classification problem, so passing, failing. So data is very imbalanced, as it quite often is with the projects we seem to do. A couple of ways of dealing with that is, looking at metrics that are weighted towards recall. And so it's sort of you're ignoring the true negatives. And then k-fold cross-validation, quite good practice just to check because the data sets were fairly small, so you're kind of rerunning the data set over and over just to check the confidence of your results. So this is a explanation of the confusion matrix. So predicted what the model predicted, what actually happened. Top left is you predicted it would be fine and it was fine. Bottom right, you predicted it would fail and it did fail. So those are obviously where you want to be. Where you're getting it wrong, there's two options. You could be predicting that it would fail, but it actually was fine, and that's not so bad because you're just doing an inspection that you didn't need to. But worse is in the bottom left-hand corner, which is you're predicting it would be fine, and you leave it, and actually there's some issues there. So that's sort of the thinking around this. And then we can effectively So this is just for one particular model. You can change the thresholds to make it more cautious or less cautious. So for the same, within the same model, you could say, okay, well, I don't mind. So naturally, we're going to go in this direction. So using the highly interpretable logistic regression model, we get this sort of result. This is about where we are. You can vary it and change it, and it depends a little bit on the data set. But we can see that actually this is pretty discriminatory. This is quite useful as a model, much better than just someone guessing at the names and so on. You're saying, actually, you've managed to say you're pushing a lot of the failures over to this side and you're bringing a lot of the passes over this side. There's still a little bit of issue there with a couple of fails, but that's vastly more useful than what they've had in the past. You're managing to inspect 7 of those 9 risk establishments with higher priority. So an important part for the Food Standards Agency is understanding the predictions and understanding what is driving those, and actually that can start to inform the way that they conduct their inspections. Or there's never been any data-driven process behind this before. They just go in and it's all officer intuition. So this is really interesting to them to start getting insight into that. So we can see that things like having a food safety management system is a really important feature. So if they've got that process to do food safety, supplier assurance, so that they're not getting dodgy raw meat in and stuff like that. That's also has come out as being really important. The feature that we derived about chains is useful, and things like reheating food, because you can imagine heating, cooling, that's that thing. So this is really interesting to them. There's a few other things in there about from the sensors, sort of about the area and stuff as well. Okay, and then we can also we mentioned those more complex models, so things like XGBoost. We can improve on the results a little bit more and entirely get rid of those failures, so that's useful to know, but then the trade-off is it's less easy to understand. This is kind of what you'd expect. So how do we deal with a complex, almost a black box model like XGBoost or random forest in a way? So we've got this really useful approach called using Shapley values, and there's libraries you can get in Python and so on. And this gives you a bit of an indication as to how a particular prediction is being made. It doesn't explain the entire model, but if you say, okay, KFC Birmingham, why did you get a high inspection rating? And what it effectively does is they look at the model prediction and approximate how much a particular feature moves that prediction away from the average value. So in this case, the establishment has no food safety management system. So that's negative, and you can kind of sort of try to quantify how bad it is. It's got no supplier assurance scheme, so again, that's pushing us in the wrong direction. And they all increase the risk there. So that's quite useful for the Food Standards Agency, and they've got a bit of a choice then. They can kind of trade off interpretability and performance, but then they also have the opportunity to add some explanation to the less interpretable models. So in terms of conclusions, as we said, the model predicts practically useful results, and it gives us insights into the drivers of non-compliance. This is still at kind of prototype stage, so at the minute this model is based on data from inspectors, so they'll have to start implementing this and change the registration process. But this is good evidence for them to do that and tells them the sort of information that they should be collecting. And then subsequent to registration, then they can sort of retrain the models and see how it changes when businesses are self-reporting. And there may be some questions there, but we try to pick out like fairly objective things like, do you have a contract for waste management, that kind of stuff. And we are helping the Food Standards Agency move towards a future of food safety. Lovely. Thank you. Cheers.